As.NET Core provides a built-in dependency injection container, also known as the inversion of control container. It's responsible for managing dependencies and providing instances of required services. Dependencies are managed during a determined lifetime. When the lifetime is over, the dependency is automatically released to the garbage collector by using the iDispose interface. There are 3 types of service lifetimes. Transient. A new instance is created every time it is requested. A unique object is provided whenever a dependent class injects the service. It's the default choice because we can skip multi-threading scenarios, mutability, and memory leaks. Transient services are suitable for lightweight, stateless applications that dispose frequently and have a small performance cost for object creation. Scoped. A new instance is created on each request or scope. The service object is shared within that request. It's recommended for web applications because it aligns with the HTTP request response lifecycle, where request objects can be reused throughout the application. Scope services are thread safe within the scope of a request because multiple requests can be processed without interference among them. One example of a scope service is the Entity Framework DB context, which tracks changes within a single request to perform database operations. Singleton, a single instance across the application. The dependency is created once and shared in all dependent classes. It's a good option for components that can be reused during the entire lifetime instance, such as configuration settings and logging or caching functionalities. It's the more performant choice regarding memory efficiency, but can cause memory leaks and multi-threading issues. Let's go to the demo. In order to understand how to apply service lifetimes, let's initially create an As.NET Core Web API. Go to the program.cs file, and to register services, we need to use the iService collection interface. I'll configure the 3 lifetimes which depend on the same implementation. Create the 3 interfaces and the dependency class itself. For this example, the interface depends on a single interface to reuse a GUID property. So add a new interface. It will contain a property called width. Implement this common interface in the 3 lifetime dependencies. Go to dependency class and implement the 3 interfaces. Every time a new instance of the service is requested, the width property should generate a new value by using the new width function. Go to the controller and rename it as DI controller. Get rid of the sample code and inject the 3 dependencies via constructor injection. Create read-only fields. Add a new get method and return an with collection. Add the HTTP get attribute. With the yield keyword, we can append values sequentially. So call the with property for each dependency. To comprehend how the scope lifetime works, I'll inject the iService provider interface that allow us to get service instances. It's not recommended to use. I'll explain why in the Drawbacks section. Request a new dependency object by using the getService method. Let's do the same for the 2 remaining dependencies. Awesome. Let's run the application. Try it out. And as we can see, transient values are different because a new instance is provided every time a service is requested. Instead, scope values are equal because we're in the same request. Singleton values are created once, execute another request, and singleton values are exactly the same. Scope values are different from the first request, and transient values are always different. What are the benefits of As.NET Core dependency injection? Loosely coupled code. Components are not bound to particular implementations. They use abstractions to handle dependencies using the dependency inversion principle. Highly testable system. Real dependencies can be substituted with mock objects. Flexibility. A dependent service implementation is easily swapped without modifying the dependent code. It's based on the open-close principle. Separation of consents. The DI container is responsible for managing dependencies, allowing the single responsibility principle to be applied in the dependent classes. And the drawbacks. DI container misuse. Exposing the DI containers iService provided directly in the components makes testing and identifying class dependencies harder. Limited advanced features. As the netcore built-in DI container is more limited than third-party DI containers such as Autofac or Unity. Complexity. Applying DI to small or straightforward systems can be an unnecessary overhead that can be solved by manually injecting dependencies. If you want to learn more, don't forget to subscribe. May the code be with you.